everyone, welcome to tutorial for Udacity mentorship. In this tutorial we are going to learn about Colab and how we can train a neural network on TensorFlow using Colab. Before starting, let me introduce about myself. My name is Hamza Zafar and I am passionate about deep learning and machine learning at scale, you can say. My achievements ranges from Kaggle profile, like I am maintaining top 30% over Kaggle, and I have implemented deep learning at scale model Alpha 0, and the machine I was using NVIDIA DGX1 and DGX2. These are the supercomputer computers for deep learning, you can say. So let's start with our tutorial. In this tutorial we are going to learn how we can use Colab and what the Colab is, how we can run our code on Colab, how we can use GPU on Colab, how we can install packages like TensorFlow or PyTorch, etc., and what's the concept of TensorFlow, and what's the concept of computational graph that is run on TensorFlow, and then we will see how we can train a neural network using the concept of computational graph. First of all, let me describe what Colab is. Colab is a Google platform that is free, and it is web-based platform. It's like you have used Amazon Web Services. It provides you free computational resources. The best thing about Google Colab is it's totally free and it provides you GPU. So you can use it to improve your Python skill or machine learning research skills. You can implement Torch, OpenCV, TensorFlow, Keras, and multiple packages that supports Python. And let's see how we can create a Colab environment. And Colab is same as Jupyter Notebook, and how we can use Google GPU and Colab. So first of all, what we have to do, we have to go to the Google Drive. Like I have opened this drive, and in Drive we have to create a folder. Let's suppose we can say test folder for Udacity, and in this test folder, if I click over there, we can see the black screen. In this blank screen, I just click right, and we have multiple options. In this option we can see more. In more we see the collaborative. If I click on that, it will redirect us to Colab Notebook or Jupyter Notebook. It has same environment as Jupyter Notebook. It shows the cell. In the cell we can run our code and we can do everything for Python or machine learning stuff. So how we can use GPU? To use GPU in Colab, we go to edit. In edit we can see this notebook setting. Just click on that and you can see the environment and setting. So we can use Python 3 or we can use Python 2. Right now we are just focusing on Python 3. So after that we can use GPU. Just click on save button. Now we are using GPU environment. We can change name of our notebook, like we can say Colab run first. So it's done, and we can define any variable in it. 1 and b equal to 2. Control shift. It is taking time because I think it's connected now, so it's running. So if I print a, it gives me a result, or if I can say b, shift control enter, it shows me the b. This is the simplest way we can use Colab cloud platform. So we have gone through like how we can run Colab, how we can do settings for GPU, and how we can create a folder on Google Cloud. So this is the description about each of the setup we have done before, like creating a folder on GPU, and we have gone through all of the process. Then creating new Colab notebook, right click on collaborative and use GPU. We have done this step by selecting GPU while going to notebook setting. Now we will go and we will see how we can install TensorFlow or multiple package on Colab. If you ever heard or used Ubuntu pip terminal command, so you just open up the terminal, you just write pip install Python package. Since right now we are interested in TensorFlow, so we can in normal Ubuntu interface we can just write pip install TensorFlow. In Collabority, you just use this exclamation mark and just run this cell. So I'm going to run this cell and it will install TensorFlow on it. It's connecting. Yeah, it's initializing. My system is connected now, and now it's running. Requirement, since I have already installed TensorFlow, so all the packages are installed already. So what's computational graph? As we know that TensorFlow works on the concept of computation graph. In computation graph we have idea of nodes where data is there and the arrows in which the data from one node follows from the other node. If we consider this whole picture, is typically a neural network, and we have a data that is passed into input node, then it is reshaped, then we have multiple function like multiply, then add biases, then apply nonlinear function, then there is another layer. So this structure represent a single layer, then we have another layer, and all the data from input to these layers passed, then there is optimizer. So this is a, you can say, abstract or more detailed view of computational graph. Before, it's a bit difficult to understand this whole process. To understand more in detail, we just consider the basic steps for computational graph. The computational graph contains 4 steps. Like in TensorFlow, when you are going to create a graph, you need to create 10 placeholders or tensors. The difference between placeholder and tensor is that tensor works same as variables, whereas placeholder are the places you define first, and when you are going to run something, so these placeholders expect to feed the data while there is some computation running or some program running. So in other sense, you can say these are the places we declare it, and on runtime this declaration is failed iterated. Then we define our computational graph, and then we create a TensorFlow session. Inside that TensorFlow session, we just run the computation graph. If we declare placeholder, we just feed the variables into that placeholder as we discussed before. So these are the 4 steps that are normally used in TensorFlow computation graph. Let's have a look on simple computation graph. In TensorFlow, so in this sample code I have created A, B and C, and I just created a constant A that has value 2, the other constant B has 10, then I multiplied them, and then I just take the output. So I just invoke the TensorFlow, then print TensorFlow. If you can see that we have when we run the session.run C is the graph, so it will give us the result. So how this computation graph looks like, we will draw over here. Discord recovery, yes. So write a document. For the sake of simplicity, I will draw where are the shapes, format, table, insert, image, chart shape, line basic. So let's say we draw our node. This is, we can say, A, that is our tensor. this is our node B. This is again tensor, then again we have C, that is equal to A multiplied by B, and these are connected with lines. So where are the shapes? Line. This is the arrow line. So insert shape line, reline. And then with the second line in the insert where is shape, object, chart, shape, line. So the code we have seen is A is 2, B is 10, and then we have C, and this is the whole computation graph. And this computation graph we just inserted into session, so we can say basic rectangular, send to back, so this is a computation graph. We can say this is the session in which this computation graph runs. Hope this thing of the concept of computation graph, how we can run a simple computation graph in TensorFlow session is clear. Now let's move towards how we can create a neural network and how we can run, or how we can optimize a neural network in To run a neural network, first we need to have a data set. So I have just created a data set using XOR function. The idea of the XOR function is that we have 5 or n number of features. On that features I just apply XOR function that gives me a output of that input variable. So if I have 5 bits, if I applied the XOR, the result is XOR output. So I just use that XOR output as my target table to use how I can train neural network. So this is generation of data, then this is creation of label, and I have just generated. Over there I will discuss how what the data actually looks like, and how the actual idea of XOR and creation of data. So if we consider nx is the number of bits or number of columns we are going to generate, and number of rows or sample we are going to create to feed into neural network. To understand how the data looks like, I am going to use only one, and just number of iteration is the same as number of training epochs we'll be using, and this generate and y. So executing this thing. Sorry for this, I just forgot to import numpy. Where is numpy? No. So you can see we have created 5 feature set. These features represent a number of bit in a sample. So we have 1 2 3 4 5, and we have just applied on XOR into this data set. It gives us the output of the operation. So in this case I just consider this thing as an input to the neural network, and this output is considered by output of neural network. We can increase it to any number of data set, let's say 5, and the data set increase. Let's train our neural network with 50 number of data set and 1000 number of rows. Then this even grows more bigger. And yeah, so how neural network works. So we have this function that is w1 into x plus b. In fact, I have just created a simple neural network with single neuron with single layer. So in this thing I just use only first layer and going to multiply input to weights and adding bias. Then I'm going to use ReLU function for non-linear activation. This is the equation, and let's have a look how neural network is generated inside TensorFlow. In this step I have just defined the seed so that every time the result would be same. Here is the placeholder that is responsible to get data at runtime. These are the variables, we can say parameters w and b, and we just multiply w and b and add bias towards them, and it returns into z, as you can see to this equation. Then we just input this variable into ReLU network, ReLU node. It gives us a value that is non-linear activation. Then we are going to compute cost, and it's the sigmoid function. Then we are going to backpropagate using random optimizer. Since we are interested to minimizing the cost, we are using minimize function, and then we are using 0.07 is learning. Then we are going to initialize variable. Then we have created the session, and in this session we are invoking the variables, and this is the whole part where the training of neural network is done. And this feed dictionary is responsible to feed the data that we have just created, and this session run is going to compute cost at every epoch of the iteration, and going to reduce or update the weights. So let's run the code. Yeah, so it's just done with 20 epochs. The one thing is amazing that the cost is static, like it's not going to decrease or increase. Maybe because we are using only single neuron, if we increase the number of neurons, that cost may be reduced. So this is my tutorial for Udacity, and you can also see my implementation of neural network Scratch, where I have used NumPy and linear algebra concept to make neural network through export data. You can find it on my GitHub, and here's every step I have declared that these are the variables, and it's more about Scratch and more technical skills about linear algebra and chain rules. Hope you enjoy my tutorial. Have a nice day. Bye.